Okay, so like I mentioned a few announcements ago, is we will not be worrying about number one. Okay, so this video should help us with the summative review. So if you're not at the summative review, you might want to get that out on a different screen. Starting with number two, I'm also going to flash back to the formula sheet, which looks something like this, which we got as well. So you should have the formula sheet as well. You don't have to worry about the top part, all the arithmetic, explicit and recursive, geometric, explicit and recursive, because again, that was like number one. We're not going to worry about that. So you can go ahead and kind of zoom in about right there. And this will show you all the different kinds of formulas that we will be using. Growth, decay, half-life, exponential growth or exponential functions, and everything like that, compound interest, population growth, so forth. So again, if we look back at our unit review, we're going to look here, number two. It says Jonathan receives $6.50 per week for cleaning the yard. This amount doubles each week. Use the correct geometric sequence to find out how much money we'll earn in week 12. Okay, so I know that geometric sequence might be something that scares everyone, but if we look here, we are just looking for a growth, right? So an exponential growth here. So that's just going to be this right here. How did I know this was the geometric sequence? Okay, so that's a good question. Since we kind of are ignoring this part of the unit, like was mentioned before, we just know that the exponential function is the growth and the half-life will be the decay. So that will kind of give us a little idea of that. So if we look at number 12, if we put it into that exponential function, it should look something like this. Y equals 650 times, this is doubling, so that's going to be 2, raised to however many weeks we are doing, which is 12 weeks. And then if we want to know what that amount is, we can simply type that into our calculator. It should be a relatively large amount, so I'm going to go ahead and type that in the calculator. 6.5 times 2 raised to the 12th power should give you, 2,000 or $26,624. So not too bad of a paycheck for 12 weeks worth, or not too bad of a paycheck for 12 weeks of work. As you can see, when you start doubling your amount, it goes relatively high, relatively quickly, which is what they call like exponential growth. That's why when something happens at a very fast rate, they'll say that, that increased exponentially, right? So that's kind of where that saying comes from. Sometimes it is an actual exponential growth, which would be something like this, where it is raised to an exponent. And sometimes it's just kind of a figure of speech. Moving on to the population question, we will be using something a little bit different, so we'll get there in a second. But let's read it first. So at the beginning of 2016, there was 2,743 people in the town of Mathland, right? So 2,743. We don't know what we're doing yet, so I'm just going to kind of just write that. Maybe I'll underline that in red. It says population increased continuously at a rate of 2.4%. So I'll go ahead and underline the 2.4% in blue since the year 2008. Write a function, do not solve, that computes the population of Mathland in 2008. So now this is kind of weird because it's actually telling us like, hey, we have to go back in time. So we know the population for 2016. We need to figure out what the population is for 2008. Well, let's just figure out what the equation is, and then we'll deal with that going back in time, right? So let's go ahead and look at our formulas. It says a continuous growth. That is going to be your major hint, right? So I'm going to look somewhere for a continuous growth, and you can see it right here, the continuous growth. And I'm going to erase this, but I just want you to see this. Continuous growth is when we are going to use this PERT function. And I know you're thinking, well, why did you put an arrow at PERT and why not NERT, right, where it says or maybe NERT underneath? The reason why is because PERT is the same thing. So we just want to call it one thing so you're not confusing yourself. I just want you to go into other classes and stuff. If they use NERT, then you know what that is, right? And I'm saying PERT and NERT because PERTNERT, right? So PERT, right? So again, we're looking at this PERT function. So the P is going to be whatever the population is currently, which we know as that 2000 number. And then the rate is going to be that percent, that, 2.4%. And then the time will be the number of years, right? So now let's go ahead and look at this. So this is going to be E to the percent, which you have to turn into a decimal, so 0.024. I turn that into a decimal. And then I need to multiply this by the number of years. Now, this is kind of where the issue comes, so I'm going to go ahead and circle 2016 and 2008. I need to go ahead and multiply this by the number of years. Well, this is the issue. We're actually going back in time, so we have to actually go -8 years, right? So this is -8 years. Now, I know this is kind of weird, but you are going back, right? Because it talks about 2016, and then it says, hey, what would be the population for 2008? So you're going back 8 years. Now, it doesn't say to solve, so you can go ahead and just circle that, because that's all you need. Maybe go ahead and put population, or y equals this, right? Because that is the function. Now, what I would do is I would solve this just in case. And the reason why I would solve this is because you should get a lower number, right? And now that might be a little bit confusing, but it says the population increased continuously at a rate of 2.4 each year since 2008, which means from 2008 to 2016, it increased. The number got larger. So that means if we were to plug this number in, this equation that we just built, right? If we were to plug that in for 2008, we should get a lower number, right? Because 2008 was before 2016. So I would just plug it in and be like, oh, good, it was a lower number. Okay, good. It was still 2000, but it's a lower number. So at least I have that going. Because if I got a higher number, there shouldn't be more people in 2008 than there were in 2016, right? Because again, it says it was increasing during this time. So again, it doesn't say to solve, so we won't, but I just wanted to like, hey, you can solve just to make sure that you are on the right track. Looking at number 5, now this is a half-life problem. Relatively easy because we're dealing with half, right? So we're just dividing everything by 2. So the amount that's happening every 4 hours, I'm just going to divide all these by 2. So I'm going to take 124 divided by 2 and get, I'm going to zoom in a little bit more, get 62. And then I'm going to go ahead and divide that by 2 and get 31. Divide that by 2 and get 15.5. Divide that by 2 and get 7.75. And divide that by 2 and get, what was it, 3.875? Something like that. Let me see. 7.75 divided by 2, 3.875. 3.875. So now we have all our half-lives, and we can see our half-life cycle. So if we wanted to complete this table, we would just say, okay, well, after 4 hours, that's our first life cycle. After 8 hours, that's our second life cycle. After 3 hours, after 12 hours, 3 life cycles, 4 life cycles, 5 life cycles. So now it says, write a function used to calculate the values in the chart below. So now let's look at this, and let's go to back to our formulas and go to our half-life formula. Oh, look, pretty easy to find. It says half-life right on it. So it's just going to be a times 1/2 raised to the x power. X is your rate. X is your number of half-lives, right? So now that's where it gets a little confusing because it's actually not the number of hours, it's the number of half-lives, the number of times it's going to be cut in half. So you kind of got to play with that a little bit depending on what the question's asking. So if I go ahead and do that, write the function. So this function is going to be y equals our a value, which I will go ahead and do in green, is 124. And we are going to multiply that by 1/2. And then we need our half-life, so we are just going to put x, because we just need the function. We were not asked to solve for a certain amount of half-lives, right? It's not like saying, hey, what about the 8th half-life cycle, right? Because then you just plug in 8 for x. Now this is where it gets interesting. It says find the amount of alcohol in Tim's body at 11 p.m. Well, you have to figure out when 11 p.m. is, right? So you look in your equation, it says at 9 a.m. the amount of alcohol in Tim's body drinking his favorite adult beverage is 124 milliliters. So again, I could go ahead and highlight the 124, but I already circled it in green. So I'll go ahead and do that, right? So that's 9 a.m. 4 hours later, I'm going to go ahead and just kind of keep track of this, right? 4 hours after 9 a.m., it is 1 p.m. 4 hours after that, it is 5 p.m. 4 hours after that, it is 9 p.m. Now, 4 hours after that, it is 1 a.m., okay? So now it says, find the amount of alcohol in Tim's body at 11 p.m. Okay, well, it is between 9 p.m. and 1 a.m. So I'm looking right here at these two. And what you could actually say, there's actually two right answers for this. You could say between 15.5 and 7.5. Oh, 7.75. That's 100% correct. And you could circle that and that could be the right answer. If you wanted to get a little bit more precise, what you would do, which, we didn't talk about this, that's why this is what you could do. But what you would do is you would take these two numbers, 15.5, add 7.75, and then divide that number by 2. So I'm going to go ahead and do that, right? 15.5 plus 7.75, and then divide, so that's 23.25. And now I'm going to divide that by 2. And what you're doing is you're just finding the average of those two numbers. And the reason why you want the average is because that's what's going to find the direct center. And again, the reason why I'm finding the direct center is because I know 11 p.m. is directly in between 9 p.m. and 1 a.m. So if it would have asked for like 10 p.m., it would have been a little bit harder, right? Because that's not directly in half. So just know that this is kind of a different way. That's why we didn't go over it in class. But I'm going to go ahead and divide this number by 2. And get 11.625 milliliters. So again, both of these are the right answers. I don't want you to think that one is better than the other. Both of these are the right answers. There we go. So don't think that one is better than the other. I just want to show you that you could actually find the exact amount at 11 p.m. just because it gave you a nice clean number at directly in between 9 p.m. and 1 a.m. The last thing we can kind of talk about is number 6 before I end the video. So number 6 is just asking whether it is a growth, decay, or neither. So let's talk about this. So we're going to talk about this first one, and we didn't actually talk about this, or not at least in great length, but if there is a negative here and here, so if there's a negative in both, this is actually neither. So we didn't really talk about that. This isn't a major thing on the test. That's why I didn't really focus on it too much, but that would be neither. And the reason why it's neither is because both of those x's will have it reflect over both of those negatives will have it reflect over the x-axis and y-axis. And in doing so, it doesn't make it grow or decay because it's going to have a couple asymptotes, which, again, if that's not familiar to you, don't be too concerned about that when it comes to the test on Friday. Now, this B, on the other hand, 6B, you should be more familiar with because the only thing that I'm looking at right here is this here. And since that is a fraction, I know it is a decay. If that was a whole number, then it would be a growth, and then I would have to worry about if there's negatives, right? Then, okay, negatives will tell me decay or growth. But if it's a fraction, so 3/8 is a fraction less than 1, I know it's decay. And if it is a whole number, 1, 2, 3, and maybe I should even rephrase whole number, and if it's a number greater than 1, right? So even if it's 1.5, it's still an increase, it's still a growth. So when I say a fraction, I mean a number less than 1 and greater than 0. And when I say a whole number, I guess I shouldn't say whole number. I should say a number greater than 1. So 1.5 5 halves is still a growth, right? Because it's greater than 1. So that's kind of it for this video. I hope I didn't go over 10 minutes too much. I wish I had a clock going. But there's the first part of the summative review. I'm going to go over the next ones in the next couple videos.